Question 1. The implications of improperly handling refrigerants during a system service visit go far beyond system performance. Carlos, an HVAC technician, arrives at a home to service a split AC system using R400 Tina. After diagnosing a restriction in the TSSB, he begins to remove refrigerant from the system using a manifold gauge, but skips connecting a certified recovery machine. He vents the refrigerant directly into the atmosphere to save time and says, well, R400 Tina isn't ozone depleting, so it's not that serious. What is the most accurate statement regarding Carlos's actions? A. Carlos is correct since R400 Tina does not deplete ozone and is not covered under EPA Section 608. B. Carlos's actions are illegal under EPA Section 608, which prohibits venting any refrigerants. C. Venting is acceptable for small residential units as long as it's under 5 pounds of refrigerant. D. Only EFCA Chief C refrigerants are restricted from venting under federal law. Answer. Correct answer. B. Explanation. Under EPA Section 608 of the Clean Air Act, venting any refrigerant, including HFCs like R400 Tina, is strictly prohibited. Although R400 Tina does not contain ozone-depleting chlorine atoms like EFCs/HFCs, it has a high global warming potential. Carlos violated federal law by not using certified recovery equipment. The EPA mandates the recovery recycling equipment for all refrigerants when opening a system. Non-compliance can result in fines up to $44,539 per day per violation. It's a misconception that only ozone-depleting substances are regulated. Global warming impact is also a regulatory concern. Question 2. By comparing sequence of operation between a digital and a programmable thermostat, what can be concluded about their performance in energy-efficient HVAC control? A. Programmable thermostats offer no additional benefit compared to digital ones in regulating temperature cycles. B. Programmable thermostats can automatically adjust set points based on user-defined schedules, enhancing efficiency. C. Digital thermostats always include occupancy sensors, which improves heating and cooling only when spaces are occupied. D. Mechanical thermostats are more efficient because they don't rely on electronics, less likely to fail. Answer. Correct answer. B. Explanation. Programmable thermostats under Energy Star guidelines allow users to set temperature schedules, reducing energy use when spaces are unoccupied. Unlike basic digital thermostats, programmable ones can vary temperature throughout the day without manual adjustment. According to DOE studies, this can lead to 1030% savings in energy costs annually. Digital thermostats are limited to map input, while programmable models reduce human error and enhance comfort automatically. Mechanical thermostats lack precision, and occupancy sensing is a feature of smart, not standard digital thermostats. Question 3. Given the circumstances, Mia is diagnosing a residential gas furnace that shuts down after a few minutes of operation. She notes that the flame sensor becomes discolored and the furnace cycles off during heat-in. What is the most likely cause of the short cycling in this scenario? A. Faulty thermostat sending false signals. B. Clogged air filter reducing airflow. C. Dirty or faulty flame sensor not verifying ignition. D. Inoperable blower motor not engaging. Answer. Correct answer. C. Explanation. Flame sensors verify the presence of a flame during ignition. If the sensor is dirty, oxidized, or faulty, it fails to detect the flame, leading to the gas valve closing as a safety protocol and the furnace shuts down. This is part of modern furnace flame rectification circuits, a built-in fail-safe per ANSI Z.47. While other options like air filters or thermostats could affect performance, they typically cause immediate shutdowns post-ignition. Regular maintenance should include cleaning the flame sensor with steel wool to prevent this issue. Question 4. The relationship between electrical resistance and motor performance can often be misunderstood during HVAC troubleshooting. If a technician reads high resistance across motor windings but finds continuity, which condition is most consistent with the findings? A. The motor is in excellent condition and functioning normally. B. The motor windings have shorted and must be immediately replaced. C. The motor windings are degraded or overheating due to insulation breakdown. D. The run capacitor has failed and is causing high resistance. Answer. Correct answer. See explanation. High resistance with continuity across motor windings typically signals deterioration of insulation or corrosion in the windings, causing excessive heat and inefficiency. Per NEC Article 430 and NEMA motor testing standards, motors showing elevated resistance values should be further analyzed using megameter testing. If resistance exceeds expected norms, motor life is compromised, often due to age or ventilation. The capacitor affects startup torque, not winding resistance, and shorted windings usually show very low or zero resistance, not high. Question 5. While examining the installation of refrigerant lines in an attic, technician James notices that the suction line insulation is frayed and partially missing. The line is exposed to ambient attic temperatures exceeding 120 degrees. What impact will this have on system performance? A. Increased cooling efficiency due to greater heat exchange. B. Reduced compressor temperature and energy savings. C. Higher superheat levels and potential compressor overheating. D. No impact since attic temperatures do not affect refrigerant state. Answer. Correct answer. C. Explanation. Exposed suction lines in high heat environments absorb ambient heat, raising superheat levels and reducing refrigerant density. This leads to compressor strain, reduced cooling, and system inefficiency. The suction line must be properly insulated to prevent heat gain. ASHRAE guidelines and Manual D from ACAT stress the importance of insulating low-pressure lines, especially in unconditioned spaces. If neglected, long-term consequences include compressor failure, increased energy use, and inconsistent cooling. Question 6. During the process of routine preventive maintenance on a heat pump, technician Olivia observes that the system engages the auxiliary heat more often than expected, even when outdoor temperatures are above 45 degrees. Which of the following is the most likely explanation? A. The reversing valve is stuck in heating mode. B. The defrost board is malfunctioning and misreading coil temperature. C. The thermostat is misconfigured or programmed for emergency heat mode. D. The compressor is running at too high of capacity. Answer. Correct answer. C. Explanation. If auxiliary heat, usually electric strips, activates at higher outdoor temps, is likely a thermostat programming or wiring issue, especially if set to emergency heat or a non-heat pump setting. This leads to increased energy consumption and defeats the purpose of efficient heat pump operation. According to NEC Article 424 and ARI guidelines, thermostats must be properly configured to backup heat only under load conditions or defrost cycle needs. The other causes would affect heat delivery, but not necessarily trigger auxiliary heat prematurely. Question 7. To determine whether a technician correctly evacuated a residential HVAC system before charging, what instrument reading provides the most reliable confirmation of deep vacuum? A. Pressure gauge shows -15 psi. B. Manifold gauge shows 0 psi on both low and high side. C. Micron gauge reads 400 microns and holds steady. D. Analog gauge, needle is fully to the left. Answer. Correct answer. C. Explanation. A micron gauge is the industry standard tool for verifying deep vacuum, which is required to remove moisture and non-condensables before charging with refrigerant. 400 microns or lower indicates effective dehydration of the system. According to ASHRAE Guideline 3 and EPA best practices only, a micron gauge can verify vacuum quality. Pressure gauges can show 0 but still contain moisture. Air holding, a steady micron reading confirms there are no leaks or moisture boiling off. Question 8. As a result of poor maintenance, a client's indoor air handler has a heavily contaminated evaporator coil. Technician Nathan notes that airflow through the coil has significantly dropped. What long-term system issue is most likely if this condition persists? A. Reduced latent heat removal and ice formation on the coil. B. Higher airflow and improved energy efficiency. C. Increased head pressure and low refrigerant subcooling. D. Enhanced dehumidification and longer equipment life. Answer. Correct answer. A. Explanation. A dirty evaporator coil obstructs airflow, reducing heat exchange and causing refrigerant to remain below its evaporation temperature, leading to ice buildup and inefficient operation. According to ACAT Standard 4 and EPA HVAC maintenance guidelines, evaporator coil cleaning is essential for airflow performance and system health. Reduced airflow affects both sensible and latent heat removal. decreases comfort and eventually cause compressor slugging if liquid refrigerant returns. Question 9. The general consensus is that transformer failures are among the top causes of control circuit malfunctions in residential systems. What test is most appropriate to verify whether the control transformer is functioning properly? A. Resistance test across the secondary winding for continuity. B. Amp clamp reading on the line voltage side of the transformer. C. Voltage test across the secondary terminals expecting 24V output. D. Capacitance test on the primary winding. Answer. Correct answer. C. Explanation. To verify proper transformer function, measure voltage across the secondary terminals. It should be around 24V AC. This confirms that the transformer is supplying control voltage according to NEC 725 and NATE standards. This is the primary test to check transformer output under no load or load conditions. Continuity or resistance tests only confirm the winding is intact, but performance amp clamp tests do not validate voltage output, and transformers don't have capacitance as part of their operation. Question 10. From a practical standpoint, what is the main reason to avoid overcharging a residential AC system during refrigerant charging? A. It improves evaporator coil saturation and increases latent cooling. B. It reduces suction pressure and keeps compressor cool. C. It leads to high head pressure and potential compressor damage. D. It helps reduce superheat and allows better ETEC speed control. Answer. Correct answer. C. Explanation. Overcharging. A system increases condensing pressure, which causes compressor overloading, elevated power consumption, and can trigger high-pressure safety cutoffs. This also reduces system efficiency and shortens equipment lifespan. ASHRAE 15 and 34, as well as manufacturer charging guidelines, emphasize charging based on subcooling or superheat, depending on metering device. Overcharging does not improve performance and in fact leads to floodback and oil dilution in compressors. Question 11. Under the assumption that technician 0 arrives to troubleshoot a split system air conditioner, the system's low side pressure is abnormally low and the superheat reading is very high despite proper charge according to subcooling. After inspection, 0 notes partially closed TSB valve. What is the most plausible explanation for these observations? A. The evaporator coil is flooded, causing low superheat. B. The partially closed TSB is restricting refrigerant flow, causing high superheat and low suction pressure. C. The compressor is overcharged, causing low pressure on the low side. D. The outdoor condenser coil is dirty, causing low side pressure. Answer. Correct answer. B. Explanation. A partially closed TSB thermostatic expansion valve restricts refrigerant flow into the evaporator, reducing the evaporator load and refrigerant quantity inside it. This causes high superheat because the refrigerant evaporates too early and suction pressure drops. The condition correlates to the symptoms Sarah finds. Overcharged systems typically cause higher suction pressures, and dirty condensers raise high side pressure, not lower the low side. This aligns with principles in ICAO Manual S and the refrigeration cycle theory. Question 12. In the context of ladder safety, Mark must climb to access rooftop equipment for maintenance. The ladder angle is critical for safe use. What is the correct angle between the ladder and the ground for safe use? A. Approximately 45 degrees. B. Approximately 60 degrees. C. Approximately 75 degrees. D. Approximately 30 degrees. Answer. Correct answer. C. Explanation. According to OSHA Standard 1910.23, the recommended ladder angle is about 75 degrees or a 4:1 ratio for every 4 feet in height. The base is 1 foot out. This angle provides optimal stability by balancing the risk of slipping and tipping. A shallower angle like 30 or 45 degrees increases the risk of ladder slipping out, and steeper angles close to 90 degrees tipping backward. Proper setup is crucial to prevent falls, the leading cause of injury in HVAC fieldwork. Question 13. Based on the information from a recent service call, John finds that a system's brake trips repeatedly when the compressor starts. After inspection, John suspects locked rotor condition. Which test can best confirm locked rotating compressor? A. Checking continuity with multimeter across terminals. B. Measuring locked rotor amperage array with clamp meter during start. C. Measuring voltage across the capacitor terminals. D. Measuring resistance across the compressor motor windings. Answer. Correct answer. B. Explanation. The locked rotor amperage array test measures the current drawn by the compressor motor at startup. A locked rotor condition results in abnormally high starting current, causing breaker trips. Measure array requires specialized equipment or current clamps during startup. Continuity or resistance tests alone don't identify rotor lock. Capacitor voltage relates to start-run components but not the rotor status. This aligns with NEMA motor testing standards and NEC electrical safety practices. Question 14. In terms of personal protective equipment, PPE is about to work on an electrical control panel with 240 of supply, with PPE is essential to protect ML from arc flash hazards. Safety glasses only, B. Insulated gloves rated for electrical work, face shield and flame-resistant clothing, C. Standard work gloves and cotton clothing, D. Respirator and earplugs. Answer. Correct answer. B. Explanation. NFPA 7-tie mandates using arc-rated gloves, face shields and flame-resistant clothing when working near energized electrical panels to protect against arc flash burns and shock. Safety glasses alone do not protect against arc flash, and standard gloves, cotton clothing can ignite. Respirators and earplugs do not address arc flash risks. Proper PPE prevents serious injury and complies with OSHA safety regulations. Question 15. Considering the evidence, a technician finds the refrigerant system charging label superheat method, but the system has fixed orifice metering device NTXV. What should the technician do to properly charge the system? A. Use subcooling measurement method instead of superheat. B. Continue using superheat method as it applies to all systems. C. Charge based on liquid line temperature only. D. Charge until compressor current reaches maximum. Answer. Correct answer A. Explanation. For fixed orifice metering devices, the subcooling method is used because the system's refrigerant flow is not modulated by evaporator load, making superheat unreliable. The superheat method applies to T6V systems where superheat indicates proper evaporator feed. Charging by current or liquid line temp alone is not reliable. This is consistent with manufacturer guidelines and a CAM manual. Charging procedures. Question 16. Given the circumstances, a technician must recover refrigerant from a residential system containing a small leak but notices the recovery cylinder has reached its pressure limit and is too warm to hold safely. What is the best next step the technician should take? A. Continue adding refrigerant to the cylinder. B. Stop recovery, let cylinder cool, then continue recovery later. C. Vent refrigerant to atmosphere since cylinder is hot. D. Use a different certified recovery cylinder. Answer. Correct answer. D. Explanation. Recovery cylinders have pressure limits. Exceeding them can cause safety hazards. The technician must switch to another certified cylinder or allow the current one to cool completely before continuing. Venting refrigerant is illegal under EPA Section 608. Continuing to add refrigerant risks cylinder rupture. Proper refrigerant handling aligns with EPA refrigerant management regulations and safety standards. Compressed gases. Question 17. When faced with a customer complaint about insufficient heating, technician Laura discovers the heat pump defrost cycle runs excessively, limiting heat output. Outdoor temperatures are fluctuating near freezing. What adjustment can Laura make to improve system performance? A. Disable defrost cycle entirely to increase heat. B. Adjust the defrost control board's timing to reduce frequency. C. Replace the reversing valve to prevent unnecessary defrost. D. Increase auxiliary heat lockout temperature to prevent early aux heat. Answer. Correct answer. B. Explanation. Excessive defrost cycles reduce heat availability because the system switches to cooling mode to melt frost. Adjusting the defrost control timing per manufacturer's specifications reduces unnecessary defrost during mild conditions. Disabling defrost risks coil damage and ice buildup. The reversing valve's function isn't the issue, and adjusting auxiliary heat lockout affects backup heat, not defrost frequency. Follows RE defrost control recommendations. Question 18. From the perspective of refrigerant leak detection, what is the most effective method to pinpoint very small leaks in an HVAC system? A. Soap bubble test on suspected joints. B. Ultrasonic leak detector or electronic leak detector with sensitivity for low ppm. C. Visual inspection only. D. Using nitrogen pressure only. Answer. Correct answer. B. Explanation. For very small leaks, electronic leak detectors calibrated for low ppm or ultrasonic leak detectors provide high sensitivity to detect escaping refrigerants that soap bubbles or visual inspection cannot detect. Nitrogen pressure helps locate leaks by pressurizing but does not detect leaks by itself. EPA recommends sensitive leak detection for system compliance and environmental protection. Soap bubbles are good for larger leaks only. Question 19. Throughout the course of troubleshooting, a furnace Eric finds that the ignition system sparks correctly, but the burner flame fails to establish, the gas valve seems to open, and the igniter is functioning. What is the most likely cause of this problem? A. Faulty flame rollout switch open circuit. B. Blocked burner orifice restricting gas flow. C. Thermostat wiring error. D. Blower motor failure. Answer. Correct answer. B. Explanation. If the igniter sparks and the valve opens but no flame forms, blocked or dirty burner orifices are a common cause, restricting gas flow and preventing ignition. Flame rollout switch issues generally cause shutdown after flame ignition. Thermostat wiring would affect system initiation, not gas flow. Blower motor failure doesn't prevent ignition but can cause overheating post-ignition. This is consistent with NFP 54 and combustion safety guidelines. Question 20. From a historical standpoint, why has the HVAC industry shifted from using EFC refrigerants to HFCS and newer refrigerants like R410? A. Because HFCS have zero global warming potential to BD due to the Montreal Protocol's regulations on ozone-depleting substances. C. Because EFCS is HFCS were cheaper but less efficient. D. Because HFC refrigerants require simpler equipment. Answer. Correct answer. B. Explanation. The Montreal Protocol phased out ozone-depleting substances like EFCS R12 and HFCS R22 due to their chlorine content that damages the ozone layer. HFCS like R410 do not contain chlorine and thus do not deplete ozone, though they have hitherto. These shift aligns with global environmental policy and regulations including the Clean Air Act and SAP program. Cost and efficiency was secondary to environmental impact, and equipment complexity increased with some new refrigerants. Question 21. From multiple perspectives, a technician inspects a furnace that frequently triggers the high limit switch and shuts off during heating cycles. The blower motor runs continuously, but airflow feels weak. What is the most likely cause of the high limit trips? A. Dirty air filter causing restricted airflow and overheating. B. Faulty thermostat sending intermittent signals. C. Malfunctioning gas valve allowing excessive fuel flow. D. Blocked condensate drain causing pressure buildup. Answer. Correct answer. Explanation. The high limit switch trips when the heat exchanger temperature exceeds safe limits, usually due to restricted airflow from a dirty air filter, dirty blower wheel, or blocked ducts. Continuous blower operation with weak airflow worsens heat buildup, triggering the limit switch. Thermostat or gas valve issues do not directly cause overheating, and condensate drain blockage affects cooling or high-efficiency furnace drainage, not limit switch activation. This is consistent with manufacturer guidelines and ACAM maintenance standards. Question 22. With respect to lockout-out procedures, technician owner prepares to service a residential heat pump compressor. Which step is essential to ensure electrical safety before servicing? A. Disconnect the power supply in place. A lock and tag on the disconnect switch. B. Inform the homeowner to turn off the thermostat. C. Remove the compressor fuse without locking out the power. D. Simply unplug the thermostat wiring. Answer. Correct answer A. Explanation. OSHA Lockout Gut Standard 29 CFR 1910.147 requires that power sources be physically disconnected and secured with a lock and tag to prevent accidental energization during maintenance. Informing homeowners or removing fuses without lockout does not guarantee safety. Lockout Gut ensures compliance and prevents electrical accidents, protecting the technician from unexpected energization. Question 23. Considering the evidence, a technician checks an air handler's blower motor and finds it running at 60 Hc, but the RPM is below the rated speed. The motor is PSC type and voltage checks out normal. What could be causing the reduced motor speed? A. Failing start capacitor causing insufficient starting torque. B. Improperly sized ductwork increasing airflow. C. Excessive refrigerant charge reducing system load. D. Thermostat calling for cooling instead of heating. Answer. Correct answer A. Explanation. Permanent split capacitor (PSC) motors rely on the start plumb capacitor for initial torque and efficient running speed. A failing capacitor can cause the motor to run slower or stall under load despite correct voltage and frequency. Improper ductwork or refrigerant charge does not directly affect motor speed. Thermostat mode does not affect motor RPM. This aligns with NEMA motor standards and capacitor troubles. Question 24. During the process of refrigerant recovery, technician Brian notices that the recovery machine is pulling a deep vacuum, but the micron gauge never drops below 1000 microns. What should Brian infer from this observation? A. The system is properly evacuated with no leaks or moisture. B. There may be moisture in the system or a vacuum leak. C. The recovery machine is defective and must be replaced. D. The refrigerant charge is too high, causing pressure buildup. Answer. Correct answer B. Explanation. A micron reading stuck above 1000 microns usually indicates moisture presence or leaks, preventing deep vacuum. Moisture vaporizes and limits achievable vacuum, while leaks let air in. Proper evacuation requires micron levels below 500 for residential systems as per EPA and ASHRAE guidelines. Recovery machine function should be verified, but this symptom most likely indicates this condition, not machine failure. Question 25. The fundamental question is, when charging a system with a fixed orifice, why is measuring subcooling more reliable than superheat? A. Because fixed orifice systems have variable evaporator loads affecting superheat. B. Because subcooling indicates liquid refrigerant quantity leaving the condenser. C. Because superheat measures compressor temperature only. D. Because superheat is unrelated to system charge. Answer. Correct answer B. Explanation. In fixed orifice systems, the refrigerant flow is constant and does not modulate based on evaporator load, so superheat fluctuates and is unreliable for charge assessment. Subcooling reflects the liquid refrigerant leaving the condenser, providing a stable and accurate measure of charge. This is supported by a CAM Manual S and manufacturer charging instructions. Superheat is important in systems where refrigerant flow just dynamically. Question 26. Across different scenarios, what is the safest practice when handling a refrigerant cylinder showing signs of rust and corrosion? A. Continue to use it if it still contains refrigerant. B. Inspect for dents, leaks, and consult standards before reuse. C. Store it outdoors without any cover. D. Vent remaining refrigerant and discard cylinder. Answer. Correct answer B. Explanation. Per Department of Transportation and EPA guidelines, refrigerant cylinders must be inspected for damage, rust, and dents before use. Cylinders with corrosion that compromises structural integrity must be taken out of service. Venting refrigerant is illegal under EPA Section 608. Proper handling ensures safe refrigerant storage and transport, preventing accidents. Question 27. Taking into account the characteristics of R22 and R400 TINA refrigerants, which statement best explains why R400 TINA systems require different components? A. R400 Tina operates at significantly higher pressures than R22. B. R400 Tina has a lower boiling point than R22, requiring larger compressors. C. R22 systems use the same oil type as R400 Tina systems. D. R400 Tina systems do not require expansion devices. Answer. Correct answer. A. Explanation. R400 Tina has a much higher operating pressure than R22, requiring components like compressors, tubing, and valves rated for these pressures. It uses POEL instead of mineral oil used with R22, making components not interchangeable. Expansion devices are still required. This distinction is critical per ASHRAE standards and EPA refrigerant handling regulations. Question 20. While analyzing the combustion process in a gas furnace, a technician notices incomplete combustion producing yellow flames and soot buildup. What is the primary cause of incomplete combustion in this scenario? A. Excess air supply to the burner. B. Insufficient air supply or clogged burner ports. C. Proper gas-to-air ratio. D. High gas pressure increasing flame temperature. Answer. Correct answer. B. Explanation. Incomplete combustion results when the burner receives insufficient air or burner ports are clogged, limiting oxygen and causing yellow, sooty flames. This leads to carbon monoxide production and safety hazards. Proper combustion requires balanced fuel-to-air ratio maintained per ANSI 0.47 and in FPA 54. Excess air causes blue flames but lowers efficiency, and high gas pressure complete combustion but isn't the primary cause. Question 29. Demonstrated by recent HVAC safety regulations, what is the most critical reason for grounding HVAC electrical systems? A. To prevent electromagnetic interference with other devices. B. To provide a safe path for fault current, reducing shock and fire hazards. C. To improve equipment efficiency. D. To comply with environmental regulations. Answer. Correct answer. B. Explanation. Grounding provides a low-resistance path for electrical faults, allowing breakers or fuses to trip quickly, reducing risk of shock, electrocution, or fire. Grounding is mandated by NEC Article 250 and ensures technician and occupant safety, while grounding may help reduce ME. Safety is the primary driver. Efficiency and environmental compliance are unrelated to grounding. Question 30. When evaluating the merits of different refrigerant leak detection methods, which method is best suited for a technician working inside a finished residential ceiling cavity? A. Visual inspection for oil stains. B. Electronic halide leak detector with flexible probe. C. Soap bubble test on accessible fittings. D. Nitrogen pressure testing only. Answer. Correct answer. B. Explanation. An electronic halide leak detector with a flexible probe allows detection in confined, hard-to-access spaces like ceiling cavities. Visual inspection and soap bubble tests require accessible surfaces and are limited indoors. Nitrogen testing pressurizes the system but doesn't locate leaks by itself. EPA and industry best practices recommend sensitive electronic detectors for precise leak location.